Okay, so far when we've written Python programs, we do something like this. And the statements that we write execute one right after another. So if I make a variable 5 here, and I make a variable 6 here, and I make a name equals George here, and then I say something like print, oh, let's make a format string. X grade for the y time. All right, so we go ahead and close that. You'll notice that the statements all run right after another. Okay, and that's it. Very boring. Statements run in seriatim. That's what we've got so far. Well, it renders Python to be of limited usefulness because there are certain things that come about. One is we might like to have our program, based on the available data that it can see, make a decision to do something automatically. We might want to have it repeat things over and over again. These are two very key tools in computing, and they're all controlled by something called a boss statement. Now, every statement we've written so far, if you look at them, they're all grammatically complete sentences. For example, this statement, you're just going to say, let the variable x point at 5. Okay? Here, let the variable y point at 6. Let the variable name point at George. Print this format string. All of these have something in common. They are all complete grammatical sentences. And when a Python statement is a complete grammatical sentence, that's a worker statement. This is a complete, so if you read it and it's a complete sentence grammatically, that's a worker statement. A worker statement executes or does something. It might print, it might assign a variable, it might update a value. You know, it could be compound assignment, any of the things we've done so far. All those things are worker statements. So the other type of statement that is in Python, and this is true of computer languages in general, is there's a statement called a boss statement. A boss statement owns a chunk of code called a block. Now, in these lectures, you're going to meet several different boss statements, the first of which is a function. Here's the reason for having functions. Functions are a little different from math class. Functions remember a procedure under a name. You can give them inputs. They can potentially have outputs, but they are different from mathematical functions in a whole array of manners. Okay, now let's talk about math functions for a minute. And let's make sure that we completely understand what is going on with a mathematical function. Mathematical functions do occur in Python. And in fact, if a function is a mathematical function, it can have some very, very desirable qualities. One of which is that it does its job without leaving a trace of anything behind. So let's talk about math here for a minute, math functions. First of all, a math function has 3 parts of its anatomy. It has something D for domain. This is the set of all possible inputs. All right. Then it has R, something called the codomain. And this is the set of possible outputs. Okay. And then there's one other part. So there's a domain. You have inputs, you have outputs, and then the third part is you have something called F. F is a rule tying each input in D, let's call it X in D, to some F of X in R. So you have some rule. Now, one thing about this rule, it's consistent. It's a consistent rule. And by consistent, I mean this. The same input makes the same output every time. Now, in a math class, Mrs. Wormwood told you, oh, we're going to study the function f of x equals x squared. Right? She told you that. What does that mean in terms of this definition I've given? Well, there are certain conventions that go on in a math class, because math classes generally at a not too high level are interested in real numbers. They think of the numbers as being a line, right? The numbers are a line, and so the domain will be the real numbers. And the codomain as well will be the real numbers. And the rule then, they're giving the name by the rule. The rule says take each x and tie to it its square. So for example, f of 4, its output is 16. Okay, and this is a mathematical function because it's the same every time. Okay, so Mrs. Wormwood's class, you learned about this. In Mrs. Wormwood's class, they also taught you about this. If you have a function f of x is, say, 1 over x, then it's going to say the domain is all real numbers except for 0. Because that's where it makes sense. And this thing is called the natural domain of a real function, all right? And the range is going to be all real numbers. And the rule is just x is tied to 1 by x. Okay, so that's a mathematical function. Now, here's something that's a mathematical function that you didn't learn about in Mrs. Wormwood's class. D is all character strings. R is integers. And len, our friend len, is the number of characters in the string. String's immutable, you know? So the number of characters in that string, it is the same every time I call on that exact same string. Okay? So len of x, this is a mathematical function. Here's another example of them. So a lot of things, upper. If we make the rule D is character strings, R is character strings, and we take the rule x goes to the string x is taken to x dot upper. That's a mathematical function because when you uppercase a string, it's going to be exactly the same every single time. Every single time you will get the same thing. It's consistent. So these are all examples of mathematical functions. Now, we have seen a function that is not a mathematical function, and that function's name is print. When you run print in Python, it simply takes whatever you give it and puts it standard output, puts it to the screen. That's it. It doesn't have an output. Now I shall demonstrate that fact to you very simply. Watch this. Okay, I'm going to open Python and I'm going to say print hello. This will print whatever output you get from hello. And what did we get? None. None. Print does not have an output value. And when a function in Python is without an output value, it returns a special symbol called none. None is the graveyard state. It is the graveyard object. There is only one none ever, and it has its own type, none type. So the output of the print function is not present. It does take an input. What is the input? The input is the string or the format string or the comma-separated list of objects that you stick into it. And its output is simply that stuff represented as a string followed by a new line. So this function print has no output. It is not a mathematical function. Print takes an input, right? We said that. Right? Whatever you put in the parentheses, a comma-separated list of objects. And then finally, print has no output. Print takes an input. Print returns none. The graveyard object. And that's the default that happens. Oh, and one other thing, print leaves something behind. That's what I wanted to say. Print has a side effect. What is it? Stuff is put to standard output. And remember, standard output, the screen, is a file. So print can put stuff in files. It can make things happen. There is a Python function called quit. It doesn't even have an input. Look at it. It doesn't have an output. But what it does do, well, let's see what happens if we try to print quit. This will be kind of hilarious. Print quit. Once quit gets called, once you invoke the function quit, Python quits. And the print just gets left behind. Okay, so Python has functions. We've met some functions. We've met len. We've met print. We've met quit. And there are three major components of functions. They can have an input or inputs. They can have an output, but if there is no output, the default output is none, and they can have side effects. Mathematical functions must have an input, unlike Python functions. They must have an output, and they're not going to just return none, they're going to return something, because there's no none in mathematics. And they cannot have side effects. And the other thing they have to do is they have to be consistent. Python functions have to be consistent. And I'm going to give you a nice example of a Python function that is not consistent at all. In fact, it's inconsistent, I would say, in the grandest and most glorious sense. Watch this. X equals input. Input is a function. Enter your name. Hit enter. Oh, it says enter your name. X is now storing the input that the user typed. There is no way that can be consistent because different users will type in different stuff. So you need to think more broadly than a mathematical function. It is desirable, in fact, it's an ideal, to be as close to a mathematical function as you can because that limits unwanted interactions. As we'll see that as we go along. But on the other hand, it is convenient to be able to remember a procedure under a name. So this is the whole business of writing Python function or of Python functions. And I think in the next one, what we'll talk about is how you actually write them.